Bem-vindos ao nosso espaço, um mergulho profundo nos assuntos mais interessantes de esportes, ciências e temas gerais do momento. Aqui você vai encontrar conteúdo de qualidade, com análises empolgantes e descobertas fascinantes que vão expandir seus horizontes. Nossa missão é trazer informação relevante de forma dinâmica e descontraída. Queremos que você faça parte dessa jornada incrível de conhecimento e diversão. Se gostar do nosso conteúdo, não esqueça de deixar seu like e se inscrever no canal para não perder nenhuma novidade. Ative o sininho também. Aproveite!
If you love science, don't forget to like and subscribe. Imagine a world in perpetual, crushing darkness, miles beneath the ocean surface. This is the abyssal zone, where sunlight is a forgotten memory. If any light manages to penetrate this far, usually just the barest scattering of blue light around 470 nanometers, it is negligible. In this realm, vision shouldn't prioritize short wavelengths like ultraviolet, or UV, light. On the surface, UV is dangerous. It damages DNA and proteins. Our own eyes, and the eyes of most surface animals, evolved strong UV filters to protect the delicate retina. Yet, in the deepest, darkest parts of the ocean, we find a counterintuitive evolutionary marvel, the UV paradox. Many deep-sea fish possess ocular lenses that appear specifically optimized to capture and amplify extremely short wavelengths, light that should have been absorbed by the water column miles above. Why would evolution engineer a lens to magnify light that literally does not exist? The answer lies in two key factors: the unique physics of water clarity and the ubiquitous presence of biological light, bioluminescence. First, let's consider the physics. Light travels through water differently than through air. Longer wavelengths, like reds and yellows, are absorbed almost instantly, which is why a deep diver sees only blue. Shorter wavelengths, including blue, violet, and true UV, are scattered and absorbed very quickly, disappearing entirely around 1,000 meters. Theoretically, no UV light from the sun reaches the abyssal zone. But the deep-sea fish are not looking for the sun. They are looking for each other. Bioluminescence is the primary light source in the deep ocean, generated by chemical reactions within living organisms. While most bioluminescence peaks in the blue-green spectrum, optimized for maximum visibility in the remaining transmission window of seawater, some specialized organisms emit extremely short wavelength light, sometimes veering into the violet or even the true UV range. Crucially, this specialized, short-wavelength bioluminescence is often used for highly directional, secretive communication, a biological encryption system. If an organism wants to signal to a specific mate or predator without alerting wider attention, a signal that quickly attenuates, like a short-wavelength flash, is ideal. This is where the lenses become paradoxical heroes. Deep-sea ocular lenses are biological masterpieces, often large and spherical, and composed of specialized proteins called crystallins. In surface dwellers, these crystallins filter UV. In the abyss, they are configured for extreme photon capture. They must collect every possible photon and focus it onto a retina that is exceptionally sensitive but small. In species facing the UV paradox, their lenses lack the UV-absorbing filters found in surface fish. This absence is deliberate. Instead, the refractive index and precise arrangement of the crystalline proteins allow the lens to collect and dramatically amplify these extremely rare, faint, short-wavelength photons. Think of it like a biological magnifying glass built specifically for violet and near UV signals. While UV light is inherently low energy, the extreme spherical structure and chemical composition of the deep-sea lens turn these few, faint short-wave photons into a detectable electrical signal. The lens effectively stretches the usable short-wave spectrum deeper into the water column than physics normally allows, making previously undetectable bioluminescent signals visible. This amplification is essential for survival. By detecting the unique UV or near UV flashes of specialized predators or potential mates, these creatures gain an essential advantage. They are seeing a private conversation in the dark, a spectrum of light that is effectively invisible to less specialized competitors and predators. The UV paradox is a stunning example of evolutionary fine-tuning. The very light we filter out for protection on the surface becomes the secret wavelength of communication and detection in the deepest ocean. Their lenses didn't evolve to withstand UV. They evolved to weaponize it, turning the most scattered and quickly absorbed light into the ultimate tool for survival in eternal darkness. It's a complete reversal of ecological rules, proving that when the environment changes, life finds the most counterintuitive solutions to thrive. For more incredible facts like this, don't forget to subscribe and turn on notifications.